So welcome everyone, and thanks for coming. And yeah, so I'm a file format person, and these days I'm fuzzing Fuchsia for Google. So yeah, also doing file formats, and this is really my world. Everything about file formats. So I'll try to look there so that I don't go far from the mic. Yeah, so everything about file format, and it's actually not my first contribution to hash collision, especially because I started to present. It's like the ending of my presentation a few years ago at Pass the Salt, and I also did a workshop on exploiting hash collisions here. And yeah, so let's start with no bullshit. And basically, the release of libtiff were announced by the tar.gz gzip were announced with MD5, and also there is some European agency that was supposedly indexing Office files with MD5. So how bad is it actually, and can we prove them wrong, and like really wrong? Especially because actually formats like XML, tar, gzip, or zip are very hard or impossible to exploit with hash collisions or generically. So it felt like it was impossible, which is exactly a few years ago at the end of the talk, Kill MD5, I thought that this format wouldn't be exploitable, and it turned out they actually are, but it was a bit tricky, which is the whole goal of this talk, so that's why the spoilers. And so short recap on hash collisions. It's there's no practical pre-image attack, so on anything, even MD2, MD4. And the current attack is like what I call buy one, get one free. It's like you make two files with some arbitrary contents, get the same hash, and basically you get one clean file validated in some way, and then you use the bad file interchangeably. So basically, you send a bill, and then instead you have a executable, malicious executable with the same that was whitelisted because it has the same MD5 or this kind of thing, or at certificate level. The problem is that the two files need to be both valid. And for some file formats, it's very easy, and for others, it's like very difficult. And like permanently, you shouldn't exploit a bug that can be fixed, and then your trick is not longer working. So actual examples of hash collisions. So again, hash collisions for this, for MD4, MD5, SHA-1, SHA-2 is built on 64 bits blocks. Everything is aligned. There is a possible prefix, and in some cases it has to be identical to the two files, or it can be different, arbitrarily different. And arbitrarily, as in no matter the content, the length, and it's just they will set the initial value for the computation. That's all. And then there is some padding, because again, everything has to be aligned to 64 bytes. And then there is a collision blocks, which is like random looking, which has very tiny differences. And then if you put any suffix after these blocks, it has to be identical so that the equality of the hashes in the two files will be kept. Again, you have more details on my workshop, and the slides are available and everything. So in practice, it gives you that for identical prefix collision. This is a fast call, so it takes typically a second to compute for MD5. But you see that it has some differences inside the randomness, the identical randomness, which is making it very hard to exploit. Then you have the more powerful chosen prefix, where basically you could choose arbitrary, like anything before, but it takes hours to compute. And then you have this unicorn of a collision that is called unicall, and where you kind of have identical prefix, but you have a predictable difference of +1 on 10th byte because crypto, and it only takes a few minutes. So it's compromise between speed and efficiency. And exploitability, of course. So typically, most formats are parsed top-down, and they tolerate appended data. So exploiting them for two files only is trivial. You just take two files, you run the chosen prefix collision, the collision blocks will be appended, and the two files after these blocks will magically have the same hash value. Okay, but this is in the case of top-down, where everything at the bottom of the file is basically not important and just used to make the two files have the same hash. And in the case of zip is actually parsed the other way around, and XML doesn't tolerate any appended data. Gzip will trigger a warning, and zip also, if the difference in the two files is too big, then the parser will not be able to locate the bottom-up structure, and therefore one of the two files will be invalid. So basically, these formats, again, are not hash collision friendly, which is why I thought this would be impossible initially. So, and then you can perform a single computation for two files, but by combining that with file format tricks, you can actually have some prefix that can be reused, and then you do one computation, and then it takes just instant, you can make instant collisions of files of arbitrary content. And okay, you have some kind of structure where you chain commands, but yeah, I mean, again, there are more details in the workshop slides and the video. So, in the case of zip, how hard is it? Well, I already hinted. First, it may not even work with the most powerful hours-taking computation, and then nothing reusable, and we'll see why. So just a simple zip archive, and okay, more dissected. You feel free to go in details later. But first thing, it's a bottom-up chain of pointers from the bottom of the file back to the top. So basically, this totally, if there is a single change in file size, all the pointers will have different value, and basically your computation will be invalid. If there is a single change of 1 bit, the initial hash value of the computation will be different, and basically your computation will be useless. So that's the first problem. And also, it's actually, the official way to parse that is bottom-up, but some parsers don't take shortcuts and just parse from the top. So you could move things around and try, but you will not have a overall compatibility. This is definitely against the spec, and basically if you try to move things around, some parsers will fail working. So it's kind of a nightmare of compatibility, overall compatibility. For example, JPEG has one library used everywhere. You exploit it, you exploit basically everything. Zip is totally the opposite. You cannot abuse the structure overall and stay fully compatible. Now, some zip parsers, okay, what I said before is you definitely, this bottom-up structure is really making a problem that even chosen prefix collision will not work. So another thing is that some data, the data you see colored here, is actually duplicated. And that's a problem, it's duplicated before and after the file contents. So basically, if you change the file contents, you will have before and after this data some metadata that will be present after. And basically, for example, the CRC of the content of the file will be present, the compressed size will be present after that. So basically, if you change anything in the content, these values will be present later, so then you will fail the computation of the collision will not work because some different content has to be present after the collision blocks. So, and another problem is that not only they have to be present and set in both sides, but they should be constant across colliding files. So how do you have different content that is present in the zip while maintaining this metadata constant? So it really sounded impossible to exploit generically for that. Now, what's technically a docx file, an office file? It's an archive of several files with subdirectories, and there is a root file that is an XML file, and it is pointing to the main doc file. So the idea is that first, does it work if you make two documents coexist in the same archive? Yes, it works. Can you move the files around as long as you update the path in the XML? Yes, it works. Now the problem is that this file is XML, and you cannot have collisions of XML. I mean, you have commands in XML, but they enforce the UTF-8 encoding. And here is a smallest example of hash collisions. As you see, it's totally not UTF-8, it's pure randomness. So basically, you cannot have the collision blocks stored in a valid XML file, either in the content or in appended data. So XML is totally collision against collision exploitation as it is. So now, if we just take two sets of files and we just point them to different paths, we'll have a different path to the original document with a slightly different path, which means the length will be kept. So that's one of the first metadata that changes, but it's good that it doesn't change so that you don't have this, the value will be kept the same in the suffix of the collisions. So now you have constant length of the block. Now you need to have constant CRCs, and there is also the problem, where do you store the collision blocks? The collision blocks, you can store them in what is called the extra field of the zip, which is something used for the high precision timestamp and these kind of things, or the mark of the web. You know, the thing that's when you download a file, the OS knows where you download this file from, and it's like, hey, you download this file from the internet, are you sure you want to open it? This kind of thing. This is stored in extra field. So basically, extra field is something that was in standard since the very first version, and is commonly used, and it's extensible, which means it's kept. So basically, it's perfect for our use case. We'll just store the collision blocks in the extra field, but because extra field is stored after the file data, we'll store the collision blocks in an extra dummy file. Now we just need to deal with the CRC. So it sounds like rooting a CRC32 is very easy, but we need to actually respect the encoding, and there's a very nice open source tool that is called CRC hack, and you just specify which bit you want to exploit for the CRC, and instantly it forges the CRC with the value you want, and you can play with uppercase or just keep the file ASCII, so it's perfect for this use case. And so basically we now have the two different files with pointing to two different paths in the same archive with the same CRC. And of course a different path, and that will be compensated by the collision blocks stored in a future file. So a funny effect of that is that typically when you do a collision prefix, they are totally invalid files. It's just a header without a body. But here, these files are actually fully standard. So these prefixes are like pre-archives, and if you do the same operation on both files at your own pace, the equality of the checks, the hashes will be kept. And if you delete the extra file you appended to this archive, you will revert to the original value of the hash. So it's very funny that even with standard tools, you have reproducible cryptographic proof of concept that maintain their magical property. We'll see later that it's totally the opposite with the gzip case. So I wrote a tool on my webpage about collisions that just does that. It identifies which format you're actually relying on, and then by using some pre-computed prefix that I already computed and gave on the website, it will instantly do collision of arbitrary documents by using all these tricks combined. So it works, it's instant because again, it's just file manipulation. It works with any Office files, pair of Office files, but it's actually working also for with EPUB or with XPS, which is the Microsoft equivalent of PDF, or with 3MF, which is the standard format for 3D printing. So basically, all these containers, it's more than just the file formats, are using this, all these containers are exploitable, and with that, like all the Office files and more. Some formats which look similar are not vulnerable. For example, Quake PK3 has no root file to abuse, and other formats like APK, JAR, XPI actually require you to store every file in the archive inside the root, and sometimes even with like SHA-2 hashes. So yeah, totally not exploitable. But at least that's a generic abuse of Office files with pre-computation and now instant collision, like in less than a second or so. So yeah, here's an overview of the file, but maybe we'll skip the technical details. As you can see, it goes back down to the original structure, and then it goes back up to the top of the file, and then it reads the data. So it's a very odd structure, and you mix that with extra field to store the collision blocks. And you have colliding files because you respect the typical collision structure. So it's valid, totally valid files, reusable, and same hash instantly. Now, let's see what about tar.gzip. And it's totally different, even though it could feel, we're actually exploiting the same kind of structure, but we'll see the result. So tar is this old stuff where everything is aligned to 512 blocks, and there is no space for commands, and it's full of padding. So you have hard-coded offsets for each of the elements, and there is a checksum that is in the header that is actually enforced. It's stored in octal. You can tell it's old. but it's so naive and so simple that it makes it very difficult to exploit. So tar seems like totally not exploitable in a generic way. You could collide two files, but that's about it. You have to redo your computation for each pair of files. Now, top-down appended data, yes, I just said, yeah, works, but nothing reusable. Now, what's a tar gzip? It's actually a tar in a gzip, and the tar doesn't care that it's in a gzip, as long as it's decompressed originally. So abusing the gzip will not interfere with with the process as long as the tar is the original one. So let's look at the gzip. It's a very simple structure. There is an offset enforced there is a magic at offset 0. And there is a root place for comments, but the comment is after the file content, so you can't really exploit it. You cannot skip some contents, so you cannot, the collision blocks cannot abuse the compressed data. Yeah, it looks like it's not exploitable. There is, again, a kind of extra field structure that is there to stay, that is usable, where you can stay, and again, like zip, it has no CRC, so that sounds like a good candidate, but again, the extra field is before the content, so it doesn't work with the standard collision structure. And it's, unlike zip, okay, it's very rarely used, so that's just for the occurrence. If you were to abuse it, it's not a big deal, but it might not be preserved either. Now, yes, we can store collision in extra fields, but yeah, again, nothing much we can do. But however, what I didn't know is that a gzip is typically the structure starting with 1F, 8B, and then the usual structure, but this structure is not the gzip file itself, it's called a gzip member. And most gzip, if not all, or like really most, are a single member. But it turns out actually in the specs that a gzip can be made of several members, and all the data of all the members is actually decompressed and appended together. So basically, if you would put a member that contains no data, it will still silently be processed by gzip, g, and zip, and it will append some null data to the compressed data. So basically, you can chain as many members as you want. They will be silently decompressed, so you can modify the gzip structure, and this will, as long as it's silently decompressed correctly, it's totally okay, even though it's not usual, even though it's actually standard. So that's here now. Suddenly we have the possibility to store some extra information in empty members with no compressed data, but with extra field. So basically, we can use the gzip members to store extra data like a typical command would. So it will be ignored by the parsers, but it can be present in the file and it won't interfere with any operation or decompression. However, this file is then not so standard, so basically this weird member structure will likely be rewritten, so entirely discarded when you manipulate the archive, unlike the pre-archive zips earlier. So now we can see this as some kind of gzip member with no compressed data as some very unusual kind of comment, and we can do the very typical collision exploitation structure like we did, for example, for JPEG. Why JPEG? Because gzip extra field and JPEG commands have the same property, 2 bytes and big endians, so you can easily abuse that. And you can chain them, and you can do exactly like we did for shattered attacks, or with SHA-1, abusing a JPEG commands length. You reuse the same structure with gzip members. It just works. It's just the same constraints. And now the best thing is that we don't even need to use the hours taking chosen prefix collision. We can use unicall if we align exactly the length to be abused on the 10th byte of the current collision, of the current block, 64 bytes block. So here is an example of a unicall-based gzip collision. So, okay, I put some ASCII strings, and these are alignments. Remember, you don't have a lot of control on a unicall, but it still gives you predictable values into 2 files, which is very unusual. Now, we have a proper unicall structure, and we have 2 kind of suffix linked together. And now it's hard for me to read. So basically, the length will be will have a 0 or 1, the extra highest byte predictable difference, which will then point to two sets of data where you put the two gzip, the original archive. And basically, by having a length of different jump of different length, a command, an extra field of different length, some longer piece of the longer range of the files will be ignored, therefore rendering to either one or the two original data. And this prefix structure doesn't depend on the archive you want to exploit. You pre-compute once, and then you can exploit as many times as you want instantly. So again, it takes, is there any timing? Nope. Basically, you take arbitrary sets of gzip files, whatever it is, and it just works instantly. So initially with this research, we went from there's no possible collision to now both of these formats have instant collisions. The collision is instant and works with arbitrary content. Gzip, but anything that relies on gzip, like tar gzip or whatever, and then things that are based on XML, zipped XML documents, multiple documents, and it covers several file formats, and many of them have a high importance, like Office files for you, or 3MF for the others who print stuff. But it's the two exploitation strategies are like very different based on the two archives. So in one case, so now I cannot read myself. So basically, in one case, you have a totally standard archive with an XML content that changes content, and you have a compensated forged CRC, and then it's pointing to different sets of documents of files from two documents inside the same archive. And in the other case, with tar.gzip, you actually abuse, you create some commands by abusing some structure of the archive, which are not so well known, and then you can chain together, you can interlace together two chains of base from the original archives. So the structure of these two abused collisions are very different, and the way you can manipulate them are very different, but at least you have the same result, full compatibility, and instant arbitrary operation. It's not computation, just file manipulation. So yeah, they both rely on extra fields and they rely on other things. So the extra members will be lost. It's difficult to read. The extra field will be lost most likely on gzip. Oops, sorry. And while the zip will maintain its original structure most likely. So one is like super robust and the other structure is like super fragile. But that's quite interesting. Now you may wonder why I care about MD5, but because of they use the same constrict, we know that these tricks will be reusable for SHA-1 and SHA-2. And actually, it's much cheaper for me, much easier for me to compute them on my personal computer. You could reproduce the exact same attacks if you have $45,000 for a shambles computation. You can redo that with SHA-1, no problem. But no one is willing to put some advertisement in such a prefix. But maybe we will see that happening. But at least it proves that it's possible, and it will apply to SHA-1 and SHA-2 in advance. So the one goal is that the problem with cryptography is that when someone has a theoretical attack, they know it's there. And it's when someone is willing to compute, if they have no exploitable file with actual impact in the real world, people will not care. And it's actually useful for cryptographers to have actually some meaningful files that will collide. So basically, when someone has the first SHA-2 attack, at least they will have very many options of what kind of file format do we want to collide, rather than having two obscure blocks with no meaning whatsoever and just say, hey, now we have a SHA-2 computation, even though I'm not sure it's going to happen anytime soon. But in the original MD5 collision was like just two blocks. It still was a standing ovation for the person who did that, but still, it had no real-world impact, which is why we had recently this argument on Twitter that MD5 is still worth using. So yeah, my goal is still to demonstrate that you can do extra attacks on top of that to demonstrate that they have some real-world impact. So can you do something to fix or prevent this? Yes. You can, districts rely on extra field. They can be, usually they are just ignored, silently ignored, and there is no scrutiny, but they could be scanned, they could be removed, and they will still be valid zip files, or means valid archive files. So basically, if you were to actually look at the content of the extra field and something very fishy like a non-ID, the length is big, and the entropy is very high, you could still detect, and you could still discard them. And multiple members in gzip is detectable, and it's still standard, even though it's not so common, but there is a format, like I mentioned earlier, that is relying on multiple members, the bgzip, which is why this is normal that it stays accepted by parsers, and G and zip most likely, most importantly. Now, the first most important thing is that libtif is not announced by MD5 anymore, now just by OpenPGP signatures, which is a kind of improvement. And again, I have my repository on GitHub where you have, so it's open source, and I have all the docs, all the examples, the scripts, the examples, pre-computed examples if you just want to prove things to your management or whatever. And I try to cover all the materials and all the formats I could find abuses for. So you don't even need to compute something if you just want to prove that it's real. But if you want to just take the pictures and the picture of something, someone else, you can just make instant collision with the scripts. But again, don't play with fire, don't rely on MD5 and prove it, because no matter your threat model, when you use a stronger algorithm like okay, SHA-1 or SHA-2, there is no guarantee that no one is playing tricks, right? With MD5, it's like my personal hard disk, it's full of, there's plenty of risk that still stay. So using MD5, I see now there are a lot of possible collision on many file formats. Yeah, there's no point, there's a permanent risk to use it, to rely on MD5. And on a personal note, I thought the formats weren't exploitable alone. And it turned out that combined with others, they were exploitable. And it was a bit the same in my personal case. I was stuck. I thought there couldn't be, I thought I was stuck in my research. And Philippe Lagadec for the office files and Jan Drono helped me for the tar gzip and the office files. So the format of researcher, alone, I was failing, and with the help of someone else, I was successful. So just keep that in mind. Sometimes you get further with someone else's help. So thanks for your attention, and do you have any questions?
So thanks, Henge, and someone has some question? Yes.
So, to your knowledge, are there 5 formats, well, archive formats or compression formats that are less susceptible to those attacks, that are really hard to attack?
Yeah, actually, in the bonus slides, other archive, I cover them. Some are too simple to be exploited. Some are not so documented or too tricky. So yes, it's so basically, a bzip2, it's bit level, it's a nightmare. Impossible to abuse, I think. And some are just too simple, and this one even has a footer that prevents appended data. RAR is a bit in between, but it's proprietary, so who cares? So yeah, and what was it? R, the old format, too simple either, there's no room for abuse in a generic way.
So we have time for another question. Yes, are you right?
I find it interesting what you said about combining file formats, As I understood that you can't attack tar, but you can attack gzip, and that's how you get it to work in the end.
Exactly.
So I'm very cautious about my interpretation of cryptography. Does that mean that it would be better to do signature or hashes on the inside file format or on the outside, or both, or is that irrelevant? Or do you not know?
I mean, when you do a signature, you do a signature of the actual content, and if your signature is not MD5 based, then yes, you will identify exactly the file, and you will not have a collision risk. So, unless your signature is using MD5, then there's no risk. Does that answer your question? Or we can
No,
talk?
I don't think so.
Okay.
We're talking about MD5 collisions here.
Okay.
So how do would it be better to do your MD5s on the inside format or the outside formats? I guess is the question.
In the case of the tar inside the compressed, the tar to be decompressed is strictly the same. Once it decompresses, the tar hasn't changed at all. From the tar perspective, the archived content is strictly the same. So it's just the whole gzip that shuffles it around and makes it with the 2 gzip archive with the same MD5, but the tar is kept absolutely identical. It's just recompressed, cut in chunks, and these chunks are interleaved together with another group of chunks, another chain of chunks from another tar files. But the tar to be decompressed is strictly the same. Hasn't absolutely. So it's even SHA-2 colliding.
Okay, thank you.
SHA-3.
Other questions? Yeah.
I'm not sure I correctly understood the fragment about SHA-2. Is there a practically possible attack using these techniques when SHA-2 hashes are used?
So SHA-2 used the same 64 bytes block processing like SHA-1, MD5, and MD4. So basically, the collisions will have the same strategy, and we rely on the same alignments, difference, prefix, suffix constraints. So basically, if there is a SHA-2 or even SHA-1, if we do a computation of SHA-1, we know they can be exploited because the constraint will be the same. So basically, when a new researcher has a SHA-2 collision, then we can say, rather than colliding arbitrary blocks, let's compute 2 PDF prefix, and we can collide millions of PDFs instantly with 2 pre-computed prefixes, like we did for MD5 or even SHA-1. Answer your question? Okay.
Other questions? No. So thanks, Henge.